Okay, so we're looking at the first question in linked list revision. And essentially, what we have to do is we're giving a main function, and we have to add code to a function stub where we sum the elements of a linked list. And linked lists are kind of scary, you know, they've got pointers, they can have mallocing and all sorts of weird stuff. But as long as you understand the structure, the basic structure of looping through a linked list, that's at least half of the content. And you'll be able to answer maybe a question 5 in the final. So the first thing we're going to do is just copy the code over. And I haven't seen this function yet. I haven't answered the question yet. So going in blind. So let's paste that over and open it with gedit. So this is going to be list sum.cn. And let's have a look at basically what we're working with. So for all linked lists, we have our struct node with our next pointer and data. And obviously the next pointer seems kind of scary, but essentially what it does is it points to the next element that's fed into a linked list. And for most of the questions that we're going to be doing operations on, we don't actually have to generate a linked list. We're going to be operating on a linked list. So all we need to really know is how to run through it using an next pointer. So here's our main function. What it's doing is it's taking in our strings, our list from the command line, and doing our sum on it. So once again, with all of these questions, is you've got to think about how you're going to break this down and what this actually does. And we have to think about if we've seen this question before, but in arrays, and we have. What it is it runs through every element of a linked list and sums it. So when I was thinking about this is an int function, so it's returning the number, which is the sum. And we're only being fed the head of the linked list. So what we have to do is find a way to run through the linked list, access the data at each point of the linked list, and add that up somehow. So we're going to achieve that. The first thing I'm going to do is make some pseudocode. So what I want to do is obviously we need to return something. So I think we're going to have to create basically a pointer to this linked list. As the head is a pointer to it, we're going to have to create something that runs through like a temporary, think of it as like a temporary variable that access each of the linked lists but doesn't change the linked list. It sort of runs in, grabs each element of the box, and then when we're finished with it, we're going to point it to the next element, and then it's going to take that element out, but it's not going to change it, and it's going to run through. And instead of just running through head and pointing head to next, if we were to do that, that would actually change the value of the linked list. But by doing this, we're copying it over, doing some function on that. So we don't have to do some summing, we can do all sorts of cool stuff with it. And then we're going to keep running that through. We're going to keep going through each part of the linked list, taking that information out, doing something with it, and then getting that node to point at the next one and keep going. So we're going to create the standard naming convention for this is creating a cur. So this is a cur pointer. And we're also going to want to create a sum, an int sum. So it's going to be a number, and it's going to sum up all the data that we have. So first thing we do is we want to struct our node, and it's going to be a node cur pointer. And you see this is exactly the same structure as head. So basically, what we've done is we're saying it's a struct node, so it's this, it has element data in it, and has an element next. And it's going to be called cur, and it's going to point to something. And what it's going to point to is head. And the reason why we don't have any of this address reference and everything like that is because head is also a pointer. And head points to our linked list, essentially. So this is what I don't honestly quite understand it fully myself, But once you see it happen over and over again, you'll see that this is exactly the same sort of code layout as running through a normal array. So we've got our head, and we're going to now create a sum, and we're going to initially have it to be equal to 0. And at the end of our function, we want to return that sum. So all we need to do is now do some operation on it. So let's think about it. If we're going to run, we want to run through linked list until the linked list finishes. And we know when the linked list is finished is that if we're at the final element, the next, because each node obviously is the next pointer, and the final element in the linked list actually points to next. So the next points to null. So we know that if our temporary variable is placed at the final, a temporary pointer, link node, whatever you want to call it, is placed at the final node, then next pointer is going to be equal to that final node's next pointer. So both of them are now going to be pointing at null. So basically, before that, if it was the second to last, that second to last next pointer will be pointing at the final one, as will our pointer, our temporary pointer, in this case called cur. So cur's next is going to be equal to the next one. It goes to the next, goes to the final one, and then we've reassigned it. Our cur's next is now going to be equal to our final node's next. And that final node's next points at null. So we know that we've finished running through the loop, finish loop, when cur's next pointer is equal to null. So when we run through the loop, we're going to say while cur next is not equal to null. Do something. And to keep running through this, we're going to have to keep pointing our cur at something. So we're going to have to say cur equals cur next. So this seems a little confusing, so let's break it down. So let's say we're at the second element. When we're equal to the second element, our cur next is pointing at the third element. So by reassigning cur, we're then going to have our cur to equal to the third element. It's going to go up to the next one, and then we're going to say third element. Our third element's pointer points to the fourth element. And we're going to keep doing that until we're finally pointing to null. So what we're going to do is, while we're doing that, we want to add up all the sum of the values. So let's say sum is equal to cur's data. And we've got to remember that in our node, we have our next pointer, and we also have our data. So sum is going to equal cur data. And then once we finish with this, this is going to return our sum, and it should be good. So let's have a look if this compiles. So it's called list sum, list sum, list sum.c. So this is all compiled well. It's a good first test for errors. So let's go list sum and see what happens. Okay, so let's see what we've got going wrong here. So while we've got cur's next is not equal to null. So we're having a pointer, which is pointing to null. So maybe it's just cur is equal to null. Let's have a look at what would happen when we would do that. And this is one of these things that sometimes you simply need to figure out if this is how it works. Okay, there we go. So it's giving us 0 now because we haven't actually fed anything into command argument. So basically what I just changed here is, well, cur's actual value isn't equal to null. And I realize now, obviously, that this makes sense because if our last element is pointing to null, when we finally, on our last element, when we point our cur is equal to cur next, our cur is actually going to equal null on the last element. So we're going to run that through again. And yeah, so the next pointer, we're at the last, we're reassigning cur to the last next pointer. And that is going to equal null, and then that will break the while loop. So just for testing sake, let's say we're going to add up 1, 2, 4, 6, and 7. And that is equal to 7. You see what I've done here is I've kept reassigning the value. What I need to do is sum is equal to sum plus the cur next pointer to data. And we can just put in plus equals for that as shorthand. Let's recompile that. And now that is going to add up all our values here. So let's do an auto test. 1511 auto test list sum. And it's all passed. And this is a very simple version of running through a linked list. Basically, this is the same structure for every one. And once you understand how this works, everything else will come in relatively easily. Okay?